Okay. Let's see. Alright, so I'm gonna turn off the lights. Okay. Alright. My name is Hanson Wu. This is the Information Security Club. I am presenting on Network and Server Security Essentials. So, overview. Well, I'm going to cover some of the basic networking stuff and terminology. Then we're going to go through building a simple server, and afterwards SSH and some Linux bash commands regarding networks and networking stuff, and finally setting up your own proxy, and finally securing a server. It's going to be basically securing the server that we create in example 2. Okay. All right, let's go. Basic networking and terminology. This will be a bit dry, of course. Oh, whoops, notification. Anyways, IP address. So what is an IP address? This should be pretty obvious. So Internet Protocol address, there's IPv4 and IPv6. Of course, IPv4 is the older one. It's limited by this many total addresses. I mean, we've all seen IPv4. Of course, we ran out in like 2011 or so, like a few years ago. Yeah. So supposedly we're going to be moving to IPv6, although there's quite a few different hacks and workarounds to make IPv4 last a bit longer. But eventually we should be future ready and prepare for IPv6 and everything we implement. So IPv6 is different instead of the something like 192.168.1.101 or something like that. That would be like a local network. Instead, IPv6 is using hexadecimal. So it's 8 groups of 4 hexadecimals, like a block of 4. For example, local host would be ::1. There's a lot more. The address space is much larger. So yeah, it's sometime in the future. It's sort of like nuclear fusion. It's always on the horizon. But sometime in the future, we're chances are we're going to be moving to IPv6. It's sort of yeah. Anyways, continuing on subnetting. So this is sort of related to IPv4. So subnetting is basically like calculating bits. It's a bit complicated. I haven't fully mastered it. I just basically learned by Googling around. Well, I didn't learn how to do it, but yeah, I mean, I just learned some of the basics. There's calculators, of course, to help you do it. But for example, this 192.168.1.0/24 is all possible IPs with the last block here sort of acting as a wildcard. So 0.1, 0.0 all the way to 0.225. So it's basically all IPs with the first 3 blocks the same, but then the last is anything. Port. So what is a port? Ports are logical constructs. They're not actually any physical entity. They're assigned to both inbound and outbound packets. They range up to 2 to the 32, I believe, or 65,000 or so. The first 1,000 or so are reserved, and they're well-known ports. Although it should be noted that they're not officially, or they're not required to be serving a certain purpose. For example, like some common conventions are, these are conventions, they're not required. Like 21 is FTP, 22 is SSH, 80, of course, good old 80 is not FTP, HTTP. 443 is used for, secured HTTP or HTTP over SSL/TLS, although you should be using TLS. If not, that's a concern. 990, that's something I personally know because I played around with FTP a lot, but that's FTPS, which is similar to HTTPS in that it's basically FTP but over SSL/TLS. So yeah, these are these ports are the inbound packets, I believe. Basically, like a server would receive data on like HTTP data on 80, but then there's the ports are also assigned for outbound packets, like you on a client computer would access google.com or something, but then the outbound packet would be assigned a very high port number. I think it's like pseudo random or something. Honestly, not too familiar with that, but that is not part of our scope. Anyways, continuing on. Proxies. So, what are proxies? Think back to history class. What is a proxy war? Anyways, so like the Wikipedia definition, much better than anything I could come up with off the top of my head. But it's an intermediary for requests from clients seeking resources from other servers. So what does that mean? This diagram, also taken from Wikipedia, is actually pretty nicely draws out what proxies do. So normal requests might be like, this is like a school computer. Your regular requests would be blocked by the school firewall, like going to Facebook or YouTube or some other entertainment resource. But then, they can't really create a whitelist of sites because there's, just countless numbers of servers and sites out there. So they can't go through every single one and say, only these are good. So you could have some proxy server or some server at home or something, and you would connect to that server, because it would be a-okay, because they can't go to that server and say, oh, we detect that it's bad, so we add it to our ban list, or something. So basically you could connect to that computer fine, and through that computer you access the your desired resource, like Facebook or YouTube or something. So the idea behind it is that you could connect to the proxy server just fine. The proxy server isn't blocked. And from that proxy server, you access the resource you desire. So basically, for our working purposes, it hides your ass. And we'll explore that more in depth later. I mean, like proxies and what they do, what you could do with them. A notable sub-definition, or a subset of proxies is the reverse proxy. It's important for organizations for various purposes like load balancing, caching, for privacy purposes, and more. It's as the name suggests, it's a reverse of the proxy concept. So instead of you requesting a resource and having to go through the proxy, it's you as a server hosting different resources, and people on the outside would first connect to your proxy server, and through that proxy server would access the resources you're hosting. And that proxy server could cache stuff like, say, your website homepage or something, like commonly accessed stuff. So instead of like serving up a new web page every single time or stuff like that, it could just hand you the ready to go resource or stuff like that. So VPN. What is a VPN? It's basically a virtualized network extending beyond physical limitations of networks. It should say "of" there. I made a typo. And this definition I came up with, it's pretty terrible actually. Let's go to the Wikipedia definition. Extends a private network across a public network. And here's a Wikipedia diagram. And again, it shows pretty more clearly than I could describe, at least, of what a VPN is. Can connect to a network and access intranet resources remotely and securely. So basically there's like, say, corporate, like regional offices, and they have their own machines, they have their own intranet, like only a locally accessible network, say the employee portal, like say corporation.com, like it might have home.corporation.com, and only if you're like at your work computer you could access that home.corporation.com. And the idea is that with a VPN you could securely connect to the work network, as if you yourself are sitting at the office, and you could collaborate with your coworkers, access the local like file server and stuff. You could do work stuff, and it would be secure from like prying eyes, so there wouldn't protect from industrial espionage and stuff like that. Basically like sort of like extending the like a local network beyond the physical limitations, so you could be remote and still access the stuff. Although for our purposes it's essentially like a proxy. Notable difference is that it's more encompassing. To speaking roughly, it's more encompassing. Like individual applications you would have to set to use a proxy server, but with VPNs you basically set it in your computer setting. Like this is all roughly speaking. There's a lot of more technical aspects, of course, but all the traffic would be sent through the VPN. Of course, there is the problem of DNS leaks, which the same is true for proxies, but basically you're accessing DNS resources, and it, instead of going through your encrypted network, it would actually go through the unencrypted and unsecured whatever local internet you're connected to, and people could track what you're doing through that. Which brings us to DNS. So DNS, domain name system. So it provides directions for network requests. They're basically databases associating domain names and various other information. So like, say, example.com or corporation.com, and who registered it, contact information and IP address. Basically, who is information. So like gonna demonstrate briefly. Go zoom in. So like who is, that sort of stuff would be hosted in the DNS. Actually, I don't know that for sure, but I'm pretty sure it is. Anyways, continuing on. My lack of knowledge. Anyways, so this picture is actually a bit small. You can't really read the text, but that says root DNS server, top level DNS server, and authoritative DNS server. So stuff like so stuff like the top level domain, it would access that for, like, say it's corporation.com, so it sees it's a .com, so it goes to the top level domain and accesses that and sees which domain or which DNS server it should look, or it should go to retrieve the specific corporation.com resource, because there might be, say, google.com, which is hosted. There might be several servers hosting different domain information on it, and only one of them, for example, might have the actual corporation.com resource. So it tells you where to go from there, and it accesses the different DNS servers until it finally gets the information it needs, and then from then what IP address corporation.com is on, and you could access corporation.com. So continuing on, now we get to the fun stuff. So the simple server. So I'm going to walk through and do a demonstration on building your own server. It's going to be a simple web and SSH Linux stack. Basically like hosting a website for web. For SSH, it allows remote access, and it has limitless expansion options. So this is basically the foundation for a LAMP stack: Linux, Apache, MySQL, and PHP. And from that, you could basically build any web app, that you might dream of. So continuing on, demonstration. Well, actually, I'm gonna go back. This, representing Linux, SSH, Apache. Haha. Anyways, all right. I'm going to demonstrate. So, let's see. I'm going to use a Ubuntu virtual machine, and I'm going to. This VM doesn't have any of these resources installed except SSH, but I'm going to go through and show you basically how to build this this server stack. All right, so I'm gonna log in. All right. Oops. So sudo service apache to status. Oh wait, no, I actually installed Apache previously. I'm sorry. I'm going to. Yeah, I took a snapshot. I was supposed to go back to that snapshot. Going to revert it. This is the good thing about VMs, is that you can do a lot of cool stuff like saving progress and reverting. Okay, so this is something I'm going to cover later, but let's ignore that for now.
I forgot, what is Apache?
Apache. So what is Apache? Apache is a web server. Basically hosts, web stuff like google.com or something. If you access it, it might be on a Apache server. Although they probably, they're a big company, they probably have something really awesome instead of Apache. And actually, I forgot to mention this, so thank you for bringing it up. I would highly suggest against using Apache because the documentation, I personally find it to be very poor and hard to understand. I think Nginx or Nginx would be a better option. Go and see it there, full screen properly. I think Nginx. Sorry, see there's a other window. Nginx I personally think would be better because it seems like its documentation is much clearer and it's actually something built after the internet bubble, which Apache looks like it's a relic from the internet bubble. Yeah, so the documentation is much better, so I would suggest trying out Nginx. Anyway, so sudo service. So I'm gonna make sure Apache is not running right now. Wait, it has start autocomplete. Okay, so unrecognized service. That's a good sign because that means it's not installed then. Okay, so I'm going to install Apache. Should be pretty fast. All right, yeah. So Apache is now installed. So
I thought you prefer the other option. I thought you prefer the other option, not Apache. What is it? Nginx.
Oh, did I say something wrong?
No, you were like you recommend people to use Nginx instead of Apache.
Yeah.
But so why don't you present it in Nginx?
Oh, yeah. So that's something else I didn't mention. So I actually learned using Apache. The Apache was the web server I learned with, because it was sort of like the web server that I knew. I didn't really know about Nginx.
Okay.
So I'm presenting using Apache because that's what I know. But if you're new to this, I suggest learning with Nginx instead. Although that's just my suggestion. Anyways, continuing on. So I just installed Apache. So yeah, it auto completes with. Wait, that's weird. Cannot reliably. Well, it started, so let's see. Actually, I'm gonna move this to a different workspace, and I'm gonna have this workspace with Firefox. So, okay, new tab got an update. I don't care. Let's see. It connects to Google. Okay, internet access is just fine. I'm gonna type in localhost. Yeah, this is working fine. it's working fine. So Apache to Ubuntu default page. So this is the the default page that comes with the Ubuntu Apache 2 version. So it just says some introductory stuff, configuration. It works. It used to be just plain it works and nothing else fancy. At least that was on Windows, but I think there was some weird stuff with the Windows version. Anyways, that's besides the point. So as you can see, we have an Apache server running. So this VM is now hosting or is now serving web pages. And if I'm going to, oh man, never mind. Let's see, ifconfig. So that's the IP address. I'm going to exit this virtual machine and go to the local machine. Yeah, this is the local, or not local, the host machine. Go to the IP address of the virtual machine, and yeah, so it accesses the virtual machine's Apache server. So essentially what's going on is the host machine is acting as a client right now, and that's the VM. And the virtual machine is acting as a server. So the host machine is the client and the virtual machine is the server in this case. So alright, that's Apache. Let's see. SSH, right. So I actually installed SSH already. Darn, I don't have a snapshot, but basically sudo apt-get install SSH, and of course I already installed it, so it's already at the newest version, but it's supposed to install some stuff like the SSH server. I think it's called SSH daemon or OpenSSH or something like that. But basically it installs the SSH server, and afterwards you're basically hosting an SSH server. I just repeated myself. I guess it's just simple as that. apt-get install SSH and apt-get install Apache, and you're done. Let's see. Yeah, that's pretty much all there is to it. So continuing on. So now that you have a Linux machine, or it's acting as a server in this case, so Linux server, let's go on to some SSH and bash commands. So Linux, or how I learned to stop worrying and love the command line. Reference to Dr. Strangelove. Anyways, try out some bash commands. So there's a lot of different bash commands that are do various networking stuff, which in my opinion makes Linux excel from Windows a lot, because Windows Windows simply can't really compare to the networking bash tools and commands and stuff, such as wget, ssh, netcat, telnet, curl. I honestly don't use telnet, but there's similar tools on Windows, but the command line is much more flexible, and you could basically create your own tools by having various flags and various inputs that you predefine and put into your own scripts. So Linux is just much more powerful in my opinion. So let's try some of these out. I'm gonna go to my terminal. Oops. Oh man, I can't full screen. So this I'm using the terminal on my local machine right now, as you could see. Instead of, well, yeah, it's on my local machine right now, but with any Linux machine, these commands should all be available. If not, you simply sudo apt-get install, and you'll have whatever resource it is. I think curl you have to install, actually. But anyways, so telnet, well, telnet and netcat, there's actually some problems accessing certain sites if you're doing a simple GET request. So I'm going to demonstrate on my personal site, and I think it's some sort of restriction with what headers, the servers detect from incoming connections. Anyways, I'm just going to demonstrate on my server. So telnet, my server, 80 for HTTP. So I'm going to do a simple GET request / for the directory root. You should just get the home page. HTTP 1.0 or something like that. Oops. Yeah. So you get my you get my website, and it's a bit malformed because the terminal isn't big. The terminal window isn't big enough to hold like my ASCII card, but I'm going to go to my website, and as you can see, this is what it is, and you know, it's what I got from the telnet request. So the same can be done with netcat, although netcat also could do a lot of other things such as port scanning, some others that I can't think of off the top of my mind, but it could do the exact same thing as telnet in this case. I think I think you type in pretty much the same thing. It should be 1.1 or 1.0 should be fine, but anyways, yeah, so I got the exact same thing. Alright, so that is netcat and telnet. So curl. So curl is sort of like wget, which I'll cover later, and is basically like what I just did for netcat and telnet. It gets a web resource in textual form. Let's see if the manual page explains better. Transfer URL. Oh, okay. I guess a demonstration will show what happens. So curl, I'm going to try example.com. It should get the source code, the HTML source code. Yeah, so this domain is established to be used for illustrative examples. Let's go through our browser, example.com. Yeah, source. Yep. So it basically just, you know, gets a web resource in text form. So if instead of HTML it just had like some text or something, then it would get that exact same text. So it's basically fetching that resource. And wget basically does the exact same thing but downloads it to a file, I guess, roughly speaking. Yeah, I'm not going to demonstrate. There's some other stuff I have to cover. SSH. So SSH in a way is like remote desktop. So I'm going to SSH into my Ubuntu VM that I just downloaded that I just installed Apache on. So I have a alias that basically does SSH and then an IP address, like for example this. But I'm going to use my alias because I can't remember my VM address. So SSH dev, and oh, something went wrong. Huh. Okay, that wasn't supposed to happen. Okay, so that's the address I have. 132. Oh, I guess that explains it. Yeah, that's different. Okay, I'm just gonna do this manually. SSH 1772.16.169 132. That right? 16169.132. Okay. Rating at Ubuntu. Yeah, it's so I've SSH'd into that machine, and I could basically do anything on the command line, and it would be doing that command line stuff on the machine I've SSH'd into. So it's like command line remote desktop. Like if you ever use the Windows remote desktop, it's sort of like that, except with command line. So I could do stuff like sudo apt-get update and upgrade or something like that, and remotely update my computer or various other things. SSH is pretty awesome. Anyways, oh yeah, I demoed that already. So that's Dr. Lovejoy reference. Okay, continuing on to proxies. So this is the so if the previous stuff is exciting, this is even more exciting. So recap, proxies are basically accessing network through another machine. There's a wide range of uses: bypass regional limitations, defeat censorship and firewalls, and security in an unsecure environment. So this is another diagram drawn differently, if it helps to understand better. So basically, this machine here, this green line is encrypted. This is regular communication. So what's going on here is that here's a firewall that you are behind, and you're trying to access the internet through the firewall. But of course, the firewall is an evil meanie blocking your precious content, or some regional limitations or stuff like that. So what in this case, what a proxy would do is that you connect to your home router, like a machine you set up at home, and then from there you access the web resource. So the proxy would be you connecting to the home router, and the idea is that from the home router that you're connecting to, everything is a-okay, and you're utilizing that, and also the fact that you could connect to the home router, or the machine at home. So demo, of course this is another diagram. I mean, just different ways of representing proxy. So anyways, let's do some exciting stuff. So I'm going to go into my VM. Let's see. Okay, so what I've got here is Firefox, and so in order to do this proxying thing, I'm going to install an extension called Foxy Proxy, and this is available on Firefox. I'm pretty sure they have a Chrome version. I don't know how well it works. It should work fine though, but I'm familiar with the Firefox version, so I'm going to use the one on Firefox. Anyways, I install the extension. Need to restart Firefox. Okay. Alright, restarted Firefox, and there's the Foxy Proxy extension. So I'm going to go to a site called whatismyipaddress.com, and oh man, there's ads. Never mind. I'm gonna install AdBlock Plus. Yeah, ads are annoying and they slow down your internet. I want to browse faster. So sorry, this would be just one moment. Oh, I don't need to restart Firefox. So, oh, it's actually instantaneous. So you can see it's spinning, it's transferring network data. But the important thing is here. You see the ISP, or Internet Service Provider, is different. And if you look at the map estimating the geographic location, instead of California, it is that Maryland? I don't know my states well, but Washington D.C. So this is basically in New York. So this is the East Coast. But the bottom line is that I am now accessing the internet from essentially a different location. So it's as if I'm sitting in, it's as if I'm sitting at a desk in, let's say Philadelphia, and using the internet from there. So what I could do is use a proxy to say Germany and access some sites have resources or like videos or like news videos or something like that, or stuff that's only that's geographically limited. So I could use a proxy and access those resources. Or since it's through a secure through a SSH connection, I could be sitting at Starbucks and SSH into my home computer, and you wouldn't be able to sniff my network traffic. Or I could get through censorship and stuff like that. Although usually this is done with VPNs, but proxies are another way to do this. Another thing to note though is that if I were to open like Chrome or something, my internet wouldn't be proxied, because this is only a setting for Firefox. And come to think of it, I should cover something else. Where is it? This. Perform remote DNS lookups on hostname loading through this proxy. So this is very important. As I mentioned earlier, there's something called DNS leaks, which basically is when you look up DNS information not through your proxy or not through the VPN. So it might look, you might think that I'm using a VPN, I'm using a proxy, and therefore I'm safe. And that might be true, but then your DNS lookups, like what URLs you're requesting, will be plain open to the world. So people could see what websites you're accessing, not the traffic you're sending necessarily, but they could see what resources you're looking at. So make sure you are you have this option checked, or you could also use stuff like Google DNS. So let's see, I think that's it for the proxy part. So next, server security. I think there's quite a bit of content I wanted to cover here, so I'm going to try to be fast with this. So we earlier covered just setting up your server, some basic fun stuff, but it's important to note that the default configuration is like where your server is behind the router and all that stuff. It's very sheltered and protected from like external threats, because the router essentially, well, I mean, there are caveats, but then for the most part the router blocks malicious external traffic. But when you enable external access, like if you're hosting a website available from like the World Wide Web, like I have radar.net, there's going to be the problem of people being able to access that computer from outside the local network, and anyone anywhere, as long as they have internet connection, can access your server. That is a big problem, because the second you open the door, so to speak, there's a lot of there's a lot of dangers. There's a very well-known and documented thing where there's botnets that brute force SSH. It's well known, it's documented. This is a blog post of someone who did a write-up investigating it. Basically, it's just root login, trying to dictionary attack the password. It's really simple and easy to protect against, but it's just an example. And like really, the second you open the second you port forward from your router, like you tell your router to allow connections from some certain port to your server, The second you do that, like metaphorically opening the door, you get brute forces. So yeah, the internet is dangerous. So protective measures, SSH. So prevent root login, certificate access. So you could, there's a configuration there's a setting where you disallow root login. So I'm pretty sure, oops, the font's small. I'll use my old terminal. So right now, as you can see, I'm from the local machine, Foxtrot. I am going to try to log into the root account directly for the VM address. No, that won't work. Okay. So this is the machine. I set up the simple web and SSH stack. I already disallowed root login, so I'm just going to show you what happens. Oh wait, no, that's the old IP address. There. So you could try to log in. I'm going to enter the root password, but it doesn't allow you to. And you could keep trying, but it just won't let you in. And eventually it's, permission denied. Let's see. Oops, this is the VM. This is the presentation. So, basic thing to do is disallow root login. It's if you follow guides online, they tell you to do that. It's like a basic security measure. Second is certificate access. I personally suggest this for security purposes, but as practical, logistic and practicality wise, I don't suggest it. It's like enabling two-factor authentication on Google. I mean, it is safe. I think it's highly recommended, but it makes things very inconvenient. Security trade-offs, convenience versus security. Basically what this does is you have a certificate file. I think it's .cer or CERT, and you would need that file whenever you SSH into your machine. You could set a custom password for that certificate, so you could even choose to have no password as long as you submit whenever you submit the certificate. Although that's bad, because if someone gets the certificate, they don't need a password. But anyways, so you could set it so then you can't even log into the server with SSH unless you have a certificate. So it adds a huge layer of security, but of course it's a bit inconvenient because there's, say you're trying to SSH in from your phone, like from an SSH app. You have to have the certificate on your phone too. Although you might never need to do that, like to SSH in from your phone, but it's something to consider. Anyways, failed to ban. So this is a pretty nifty application or package software that basically tracks your authentication logs, and when there's too many failed attempts, it blocks that IP address. You could customize it with the duration, how long the IP address is banned for, and how many attempts it takes. And pretty much anything with a log, fail to ban will be able to track, like Pro FTPD or VS FTPD, very secure FTP, and Pro FTP. I think OwnCloud and some other applications, fail to ban could protect those from too many login attempts. Another thing, not necessarily security, but it is security, but not like the other things, is visual fingerprints. So as you might have noticed, when I SSH'd in, there's these fingerprints. So you might look at this and it would look the same as another fingerprint. Like, to you, it's just a giant string of characters. It's like trying to, it's like for a human trying to confirm a a SHA-256 hash or something. I mean, it's pretty much gibberish. But what you could do is enable a fingerprint, like a visual fingerprint, I mean, and it would show a picture of it. Let's see. I'm gonna try that again. Okay, no, I didn't. Okay. I'm going to change the configuration on this host machine. Oops. Sorry, let me think about this. Okay. Where is it? There, it's near the bottom. Visual host key, no. It's commented out, but you just remove the comment, change it to yes, write WQ for write and quit. This is Vim. I assume you know it. It's just a terminal text editor. So I enabled visual fingerprint, and let's SSH in again. So what it does is it has an algorithm for taking this and turning it into a picture. There's some write-ups and like documentation online on how it does it. It's sort of like, from what I recall, it takes these different values and does some movements across this area and creates different characters and some complicated stuff. It's like trying to research how MD5 hashes work. But anyways, it creates a picture that is unique to the fingerprint. It's basically like the fingerprint in visual form. So as long as the fingerprint is different, this picture is different. And this is much easier to memorize than this. You could say that this is like a sort of diamond thing with, I don't know, glitter or something. But if I let's see, I'm going to SSH into my lamp VM. It's okay, it's on. I'm going to SSH into another machine. So remember this. I'm going to SSH into another machine. Look, it is completely different. And to you, it's just a whole bunch of like hex characters here. But this picture is much easier to memorize. Now, what is the significance of this? Well, these pictures, the fingerprint is basically saying what machine you're connecting to. And if there is someone man in the middle-ing your connection, this fingerprint will be different. And this picture will be different. And so, I mean, you might like SSH into your machine every day and you know like what it looks like. But if it suddenly changed, it's like, whoa, what the hell's going on? And you'll be able to know that, you know, someone's doing something nasty, as you know it sometimes prints out. Like when the SSH automatically detects that the fingerprint is different, sometimes it says, you know, someone might be doing something nasty. But this helps with you being able to visually, you know, see, you know, like confirm the identity of the machine you're connecting to. So fail to ban, as I mentioned earlier. What I just want to add on, what I like to do is have the ban duration -1, basically, you know, banned forever, and attempts the minimum possible, because I know what my server's password is, because the default is to ban for like 10 minutes or something, and then afterwards the botnet could just, you know, start trying to brute force in again. Apache, something to note is allowing indexes only and 403 your resources. So basically enabling index only for your resources, or for Apache, means that you can't access, let's see, I don't have an example off the top of my mind, but sometimes when you access a directory on an Apache server, it lists out the different files, sort of like a like it acts as a file server, and it has links to all the different files. It's like using a file browser, and then yeah, it's the problem is it's very revealing. It doesn't necessarily mean someone can hack into your server, but it, you know, it's very revealing. Sometimes you want it though, but sometimes you don't. I think, let's see. Linux distributions sometimes have it. Yeah, it looks like something like this. So it lists out all the different files. It's like a file explorer. In this case, they're hosting files for you to download, so they don't really care. But sometimes it's pretty revealing, and they don't need to look at all the resources you have on your web server. So you don't always want to have your files listed out. So allowing indexes only will mean that whenever there's no index.html inside of a directory, it simply won't list it. So let's say in this folder there's no index.html. That means that this directory will be completely hidden, and instead it will return a 403 unauthorized error. And that's pretty much it. I do want to bring up my old failed to ban log. Let's see. Server security, and yeah, right. Well, it's pretty much the same files, but here. So this is on my old server. So what failed to ban does is it uses IP tables to basically block IPs from connecting to your computer. So it immediately drop before you even are able to try to authenticate with SSH. So sudo IP tables -l-n, it lists the IP table policies. And there's this fail to ban SSH. So fail to ban's SSH policies. So all these are going to be, well, not this of course, but all these, as you can see here, are dropped. So all these IP addresses are from the evil botnet, and failed to ban detected from the logs that they tried to log in too many times, unsuccessfully, and it adds them to the to the ban list, and connections from them are here on in the future dropped, and they won't have any chance of connecting to the server ever again, which is fine with me because it's a botnet and I don't want them anyways. So that's pretty much it. Any questions? Want me to demonstrate fail to ban? Okay. Alright, so let's see. So this is my Debian server. I'm going to go back to the Ubuntu server, which I installed Apache and SSH on. Well, actually Apache. SSH was pre-installed. Let's see. Oh yeah. So wait, no, here. So exit sudo apt-get install fail to ban. I haven't actually seen the configuration for a while, but it's relatively simple and it's well documented online. Let's see. So, oh wait, I don't think it's executable, is it? Fail to ban client. Sudo service fail to ban status. It's running. Okay. I'm gonna look at the configuration. I think it's this Vim, terminal-based text editor. So I'm gonna check inside, and then I'm pretty sure. Okay, this is the wrong file. Somewhere, I think it's jail.config or configuration or .conf. Anyways, it should have. Is this SSH? Oh, this is the default. Does it specify SSH? Jails SSH. Okay. Max retry gosh, I don't need that many tries. Oh, I didn't use sudo. Excuse me, let me use sudo. There. Super user access, so I could modify this. Okay, drop bear. I'm pretty sure that's a different SSH client. Anyways, so max retry, I'm just gonna set it to 1. So this is specifying the log location for it to track. Yeah, it should be fine. Duration, no. I'm trying to look for where it specifies how long IP addresses are banned for. Ban time, there it is. So seconds, so 600 seconds, 60 times 10, it's 10 minutes. I don't need that. -1, so it's gonna ban forever. Alright, so sudo IP tables -l-n. Okay, so far it's empty. I'm going to try from my host machine, since I could go into my VM and unban my IP address. From my host machine, oops, not exit, SSH. Okay, this is the dev VM, which I was just in. I'm just going to enter in the wrong password and demonstrate and show that it gets banned. So permission denied. Wait, was I? Okay, it wasn't logging into root. Oh wait, no, I have to restart fail to ban because I changed the configuration. Oops. Sudo service. Sorry about that. Fail to ban. Restart. Okay. And I'm gonna do it again. Oh wait, I've already been banned. Whoops. Wait. Oops. Huh. Oh yeah, I've already been banned. Oh, I think yeah, I was using this like 2 years ago, so they might have changed it. It's reject now. But basically, point is, I can't log in. I try to connect, and it just refuses, flat out refuses. I can't even get into the, it doesn't show me the fingerprint. I can't even try to enter a password. No chance in hell. And of course, I found out online there's some like specific command you send to unban your IP address. Actually, it used to be that when you restarted the service, it did a jailbreak, so like all the IP addresses would be released for some reason, which in my opinion is pretty terrible design. But yeah, apparently it doesn't do that anymore because I restarted the service and nothing happened. That's good. So this is an old list of commands that I made way back in the day. Let's see. Okay, so as you can see there, it lists the IP addresses that are banned, and here unban an IP address. So let's give this a try. So this is the banned IP address. Copy. I'm gonna go back to the VM, paste, and instead of the variable name, I'm gonna add or insert my host computer's IP address. Add rules. Oh, it used to be drop, now it's reject. So, okay, I think I did something wrong. Let's see, reject. Okay, that went successfully. Let's list the IPs again. Yeah, and as you can see, my IP address is no longer here. Earlier, my IP address was banned, and what just happened? Scrolled all the way up. I'm sorry. So earlier you could see my IP address was banned, but now it is no longer banned because I sent the command to unban it, or to remove the rule. So to confirm that, try to SSH in again. Yeah, and I could, it gives me a chance to try to sign in again. I sign in, and there. So ifconfig. So as you can see, this is the VM's address, this is the VM host name. So yeah, I am unbanned and I can access the VM again. So fail to ban is pretty nice. It could, your computer won't be hacked into by botnets. Well, it won't be hacked into as long as you disallow root login, but yeah, it's pretty nifty because if someone tries to, like, if actual hackers actually try to brute force into your machine, then this will actually be an effective countermeasure because it will block them too. So it's not just for simple botnets, but for higher or for greater dangers. It protects you against like greater dangers. And hopefully you don't forget your password, so only one try, and well, actually you can set it to 2 or 3 of course, but this should be enough. Yeah, it's end of my presentation. Alright, any questions? Anything I should cover a bit more?
But like, what topics are we gonna like dive deeper into? Some of them.
Oh, what topics are we going to dive deeper into? Well, not that this is the extent of my knowledge, but this is the extent of knowledge that I am familiar with.
Right.
So, I mean, this is just like stuff that I learned like a few years ago, and I am pretty, I'm comfortable talking about, and I know fairly well. So, unfortunately, I probably won't be going into like presenting on the topics more in depth, but I guess I could make a future presentation, and if there's something of interest, I could, do a bit of research and familiarize myself with it and present about it.
Yep.
Because I don't know enough to, I don't have too much knowledge on certain more advanced
Right.
topics.
Yep.
Sorry, that was a drawn out explanation, but yeah. Okay, any other questions? All right, thank you for attending. It was actually pretty fun to talk about this stuff. All right, hope you guys learned a lot.
Yeah.
Woohoo.